So in this video, we will learn how to integrate by parts. So here is the basic formula that you need to remember, which is integration of u dv is equal to uv minus integration of v du. So you need to remember this formula to be able to use it. Now let's look at an example, and this will be more clear to you. So let's say we have integration of x cosine x dx. So first step is to identify what is u and what is dv. So it is always best practice to take u as a polynomial, and I will explain that later in the video, and you will see why we always choose u as the polynomial. So choose u as x here and dv as cosine x dx. So let's write it over here. U is x, du will be deriving x, which is just 1 dx. So the two unknowns that you also need to find after identifying u and dv are du and v here, since we have dv in the question. So now we know that dv is cosine x dx. So if we integrate both sides, we will get v is equal to the integration of cosine x is sine x, and now we have all the unknowns. So all we need to now do is plug in the formula. So excuse me. So now it's going to be u multiplied by v. So u here is x and v here is sine x. So it's just going to be x sine x minus the integration of v du. So v here is sine x and du here is dx, or 1 dx, which is the same thing. So dx. Now the integration of sine x is minus cosine x. So minus cosine x, and simplified, the final answer will be x sine x plus cosine x plus the constant c, and this is the final answer. So in our next question, we have integration of x squared multiplied by e to the power of x dx. So again, the first step is to identify what you're going to take u as. So we'll take u as x squared, du will be 2x, and dv here is x to the power of e to the power of x dx, and we integrate it. So now v will be the integration of e to the power of x dx, which is the same thing, e to the power of x here. And now we can plug in the formula, and I have written the formula just for you as for a quick reference. So now it will be u times v, which is going to be x squared multiplied by v, which is e to the power of x, minus the integration of v, which is e to the power of x and du. So du here is 2x. So what I'm going to do, I'm going to write u first, du actually first, and then I'll write v here, which is the same thing, e to the power of x. So if you notice something, we again need to use the integration of parts by parts for this integral, since we cannot integrate this. It's a multiplication of two functions here, and here again we need to take u and the v here. So we can take the 2 outside actually. Let me make it more simpler. So it will be 2 integration of x e to the power of x dx. So yeah, now you can see very clearly that we again need to integrate by parts here. So I'm going to erase this part over here and write, so u will be taken as x here, du will be 1, and here dv is the same thing, so that I don't need to change. So now this part over here is going to be, I'm going to write these things again, e to the power of x minus 2, open brackets now. So again the same formula, and with these values now. So uv, u is x, and v here is e to the power of x minus the integration of v, which is e to the power of x du, which is 1. I'm just going to remove it. So it's the same thing. And I forgot to mention that there's dx over here. So now I just simplify this answer and you will get 2x e to the power of x minus, or plus, because there's two minuses, plus 2 e to the power of x plus c. And this is the final answer. Here we can factor e to the power of x, by the way, outside, but it really doesn't make a difference. So if you guys realize something, we used integration of parts here in this question twice, and in the first question we used it once. So do you think there is a way of looking at the question and realizing how many times do you need to use integration of parts by parts? So we look at the degree of x. So in the second question it was a degree of 2, that indicates that we need to use it twice, and in the first question we simply had x as the degree of 1, meaning that we just need to use once the integration of part. So that's a quick way. So let's say if we had x to the power of 5 multiplied by e to the power of x, this means you would need to integrate by parts 5 times. So that's a quick way of knowing that. And the second thing I wanted to mention was, how do you know what to choose u and dv as? So let's rewrite the question actually and choose u and dv the opposite way. So let's say the question came like this. So integration of e to the power x multiplied by x squared dx, it is the same thing, but let's say you choose u here to be your e to the power of x here, and x squared dx is going to be dv. So you will get the same answer, but the main thing is, when you are differentiating, you are eventually going to hit 0 with any polynomial, right? So let's say it's in this example, this x squared is going to be 2x, and then it's going to be 2, and then it's going to be 0. But if you're integrating it, it's going to become more complex and more complex, since you're going to increase the power, and eventually you will end up increasing like this and going on and so on and so on. So let's say if you need to use like 3 times here, so you're going to make it more complex and more complex. So that's why it is always best practice to choose your u as your polynomial and everything else as your dv. So I mean, you will get the same answer even if you choose the other way around, but it's just more complex. So that's that. Now there is a shortcut method for you guys for these type of questions, when I will explain when you have a polynomial, since this method only works for a polynomial. So it's called the tabular method. It's based on a table, so you will construct a table here. So first thing will be the columns, will be u and dv, and here u we chose as x squared and dv we chose as e to the power of x, right? Now you will derive u until you get 0, so it will be x squared derive, so it will be 2x and then 2 and then 0, right? And we will integrate dv until we reach 0 here. So it will be e to the power of x, e to the power of x, e to the power of x. Now all we need to do is multiply it diagonally. So the first u multiplied by the second dv, and then the same thing for the next one, and then the same thing for the last one. Now the main thing in this one is that the sign alternates. So the first multiplication will be positive and the second one will be negative. So here, if I make more space here, it will be x squared multiplied by e to the power of x. Let me actually remove this. So x squared multiplied by e to the power of x here. So e to the power of x. Then next one will be alternating sign. So this is plus, this is minus. Now 2x multiplied by e to the power of x. And then now it's going to be a plus here. 2 times e to the power of x, and then that's it. So when you see the 0, you just stop. So now all that's left is the c. So this is a quick way. Let's say if you have, like, let's say x to the power of 5, so you're gonna quickly do it this way. So this method, keep in mind, only works if you have u as a polynomial, meaning that you have x to the power of something. We can use this method for the last question also. So let's quickly do that. So here we have u and dv. U was x here and dv was cosine x. So the derivative of x here is just 1 and then 0. And here we have sine, wait a second, yeah, it was sine x, and then here we will have the integration of sine x is negative cosine. So now cross multiply the first u multiplied by the second dv, so x multiplied by sine x, and then we do alternate the sign. So first one is plus, this is minus 1 multiplied by negative cosine, so this is going to become positive, then cosine x, and you see the 0 and you stop here. So this is the final answer. You can see that it's the same, and I just forgot the c. So in our next question we have the integration of ln x dx. So again, the first step is to identify what to take u as and dv as. So what do you guys think here? Since there is no integral for ln x, let's say if we took u, you can imagine that there is a 1 behind or here, that we have two variables here. So if we take dv u as 1 and dv as ln x dx, we won't be able to integrate this. This is the same problem that we have right now. So that is out of the question. So let's take u as ln x, and du will be the derivative of ln x is just 1 over x dx. That's pretty simple. You should know that. dv is 1 dx, and v here will be x, and that's it. So now we just need to substitute it back to the formula. So here we have equals to uv, so u is ln x and v here is x. So I'm going to write x ln x minus the integration of v, which is x here, du, which is 1 over x dx, 1 over x dx. So the x's can cancel out, so all we are left here is the integration of 1 dx here. So this is gonna be the integration of 1 is just gonna be x, and that's it. So this is the answer. And here we cannot use that shortcut method, the tabular method, since u here is ln x. It has to be a polynomial to be able to use that method, and I will show you why. So let's use u and dv. U is ln x and dv here is 1. So if you differentiate ln x, it's going to be 1 over x, and you keep going on and on and on. You don't know when to stop, basically, since you won't get a 0. If it's a polynomial, x to the power of 5, or even let's say 999, it will come to a 0, right? Since you're bringing it down, you're minusing the power 1 by 1. So that's why you cannot use the tabular method over here. So our next example is a bit more trickier, so I would need your full attention. So here we need to choose again u and dv. So let's choose u as cosine 3x, and du here will be the integration of cosine 3x, which is just minus 3 sine 3x dx, just chain rule, and u and dv here is gonna be e to the power of x, 2x I mean, and then v here is gonna be e to the power of 2x over 2. So now you can swap even. If you choose u to be e to the power of 2x and dv to be cosine 3x is the same thing. Here it does not make a difference, and you can do whatever is more easier for you. So I'm just going to stick to this right now. So now let me make more space. Let's write the formula out. It's going to be u v, u here is cosine 3x, v here is e to the power of 2x over 2, e to the power of 2x over 2. Okay, I need more space again and again. Sorry about this. Yeah, that's better. Minus the integration of v du. So v here is e to the power of 2x over 2. Multiplied by du, and du here is this part over here, which is negative 3 multiplied by negative 3 sine 3x dx. So here we can take negative 3 outside and the 2 over here. So let's do that. I'm just taking the numbers out here. Let me actually add it first and then I'll remove it so you guys can see. So minus 3 is going to be plus 3 here over 2, and we can remove these now, and this part over here also. So all we have left over in the integral is e to the power of 2x multiplied by sine 3x, and we again need to integrate it by parts. So this part now, so here dv, or sorry, u here is gonna be sine 3x, and the du is gonna be 3 cosine 3x. And one thing to keep in mind is that whatever you took as u and u and dv, you need to stick to that again. You can't change it after using it once. So this part here is going to be, I'm going to write it over here or on the next line. It's going to be u 3x sine 3x multiplied by v e to the power of 2x over 2 minus the integration of v, which is this part over here, e to the power of 2x over 2, and u, or sorry, du. So we can take the 3 outside here and leave the cosine inside. 3 dx, and 3 can go outside, minus 3. So can you guys notice something? Let me write it again. So have a quick look at the integral, and what question do we start with? We got the same question again, right? So this is an everlasting loop that we are stuck in, because we will again use the integration by parts and keep looping again and again, and it will be the same thing. So what I mean to say, let's say we do it again, integration part, we'll get sine, and then again we'll do it and we get cosine, and then keep going on and on. So let me clear some space here and simplify what we have. So we don't need these anymore. So here we have, so what I'm going to do is I'm going to replace this part over here, the integration, by what we have over here. So it's going to become, open brackets, sine 3x e to the power of 2x over 2 minus 3 over 2 integration of e to the power of 2x cosine 3x dx. Now let's distribute the 3 over 2. So this part will become just 3 over 2, right? And for the next part, this is going to be multiplied by 3 over 2, so this will become 9 over 4. I hope that's clear. And what question did we start with? What is this all equal to, this line over here? We started with the question here, right? So all of this is equal to, let me make more space. This entire thing is equal to the question, right? What we started with, e to the power of 2x times cosine 3x dx. So when you see this tells you that you're on the right track. So let me ask you a very simple question. Let's say we have a linear equation which says 5 minus 9 over 4x here is equal to x. What would you do to solve x for? You will bring this side 9 over 4, negative 9 over 4x to the other side, right? So this is exactly what we are going to do over here. So let me rewrite this entire thing. It's going to be cosine 3x multiplied by e to the power of 2x over 2. And here I'm going to merge these fractions. So it's going to become 3 over 4 e to the power of 2x sine 3x minus 9 over 4 integration of e to the power of 2x times cosine 3x dx is equal to this over here, cosine 3x. So now I'm going to bring this over to the other side. So this is going to be 1 and this is negative 9 over 4. So all we are doing here is 1 plus 9 over 4, which is equal to, this is equal to 13 over 4, right? So this entire part, I'm going to write it again. Let me actually just copy paste it this time. This entire part is equal to 13 over 4 integration of e to the power of 3x times cosine 3x dx. So how do you think now we need to get rid of this 13 over 4, right? Because we just need to find the integration of e to the power of whatever, blah blah blah. So what we can do here, to get rid of 13 over 4, we can multiply both sides by 4 over 13, right? Simple simplification. And this entire thing will be multiplied by 4 over 13. So here 4 over 13 multiplied by the entire brackets is equal to the integral, and this is the answer. You can simplify the answer, it really doesn't matter, but you have to get the logic and what you need to do. So in some questions you might need to use u substitution along with integration by parts. So in this example we can notice that we cannot directly use integration by parts. So here we need to choose a u which we can simplify or like change this integration into something that we can use integration by parts. So let's say we take u as 3x plus 9. This is just me trying. Du will be equal to 3 dx, and that's it. So here we will have 1 over 3, yep, e to the power of radical u du. So we cannot integrate this, to be honest, because we don't know how. There is a power on u here, so we need to choose u as something else. If we choose u to be the radical of 3x plus 9, this entire thing will become e to the power of u, and we know how to integrate e to the power of u, right? So let's choose u as this part over here. Now du will be equal to so half will come out, and then times 3 over brackets 3x plus 9 to the power of negative half, and we can bring this down, so I'm gonna rewrite now. So du is equal to 3 over 2 the square root of 3x plus 9 dx. Now let's rewrite it again in terms of dx now, because we need to replace dx here. So dx here is going to be equal to, we're going to bring this over there, so it will become 2 radical 3x plus 9 over 3 du. So now we are ready to substitute dx. But do we see something else over here? What is u? U is the square root of 3x plus 9, right? And we have a 3x plus 9 in the brackets. So we can substitute this entire thing by u, and that makes our life very simple. So now let's start the u substitution. Let me bring it up here. Actually, let me just remove all this because that's the simplification. So here it's going to become, I'm going to take 2 over 3 outside. So 2 over 3 integration of e to the power of u, and there is an extra u over here, don't forget that, u here, du. So now we know how to integrate this, very simple integration by parts. And we also realize that we can use the tabular method if we take u as u here actually. So let's do that. So u line and then dv, u here is u here is 1 and then 0, dv here is e to the power of u, e to the power of u, e to the power of u. And now we can cross multiply. So u times e to the power of u minus 1 times e to the power of u. So the final answer would be 3 over 2 u multiplied by e to the power of u, minus, don't forget that we need to alternate the sign, e to the power of u. And the final thing now that's left is to replace u as what we took u as from the beginning. So the final answer would be 2 over 3, open brackets, u here was radical 3x plus 9 to the power of radical 3x plus 9 minus e to the power of 3x plus 9. So, and plus c. So you might need to use u substitution along with integration by parts sometimes, like this question over here. So keep that in mind. So let's do our last example, question 7. It's going to be cosine, integration of cosine radical x dx. So we know that we can't integrate this directly since we have a radical for the sine. So here we need to use u substitution again along with integration by parts later onwards. So let's take u as radical x. Du here is going to be, actually let me write this as half since it's more easier. Du is going to be half x negative half, and we can bring this down, so it's going to become radical x down. Let me write it again. Yes, dx. And here we can rewrite this and in terms of dx. So dx here is going to be equal to 2 radical x du. I just brought this up here. And again we notice that u is e x to the power of half. So here we can replace this by u. And now let's start the method. So let's take 2 outside, 2 into, now we have cosine u multiplied by a u, extra u here, oops, du, right? And I'm going to erase all this now, need more space. Now we realize that we can use the tabular method since we have a polynomial u here. So let's do that now. So it's going to be u dv, u here is just u, derivative of u is 1 and then 0, and then dv here is cosine u. Next is going to be sine u, and then negative cosine u. Now cross multiply, we multiply like this, so it's gonna become 2 into u times sine u minus, and then again a minus, so it's gonna become a plus cosine u plus c, and we can simplify this into, so all that's left now is to substitute u as what it was. So radical x sine radical x plus cosine radical x plus c. So this is the final answer. It's very simple. Now, as always, I do have a shortcut method for you guys on the calculator to recheck your answer from the start. So let's take this example. I'm just going to take any. So we have integration of cosine radical x, right? Dx. So open your calculator and it should have the two limits over here. So let's just put 0 and 1. And remember to keep your calculator in degrees only, or radians will give you a completely different answer. And you just integrate the question, right? And you will, let's actually do this on the calculator and I'll give you the exact value. So I got the exact answer as 0.999923. That's enough now. So this is a number that you need to note down first of all. And now whatever answer you got, we need to replace x with 1 first, and then minus the same thing with replacing x with 0. So let's do that. So here I'm going to type this entire thing on my calculator with x to be 1 minus this entire thing with x to be 0, and you should get the exact same answer. If you don't, then there is something wrong. So I'm going to do that right now. So you would get the same exact answer, and if it's not the same, then this means you made a mistake. And let's say we use the same method for this question. So I got the answer of 25.7 when I put 0 integration of 1, and your final answer here, you will substitute 1 first in x here, become 2 over 3 radical 12 e to the power radical 12 minus e to the power radical 12 minus, and then you do 2 over 3, the same thing but substituting x with 0 this time, and again you will get the same exact answer. And you can try this method for any of the other questions here also, you would get the same answer. So that's all for this video. I will be making a short video for showing you guys the shortcut method, and since it's more easier of course to show rather than talk about it, of course. And thanks for watching.